integration by substitution can be a bit awkward. Let's have a look at this one. So we've got to use the substitution u equals 5 minus x squared to evaluate this integration. Okay, so every bit of the integration needs to be turned into u's. So the first thing I normally do is work out the differential of the substitution statement that we've been given there. So if I differentiate that, I get du by dx is negative 2x squared. Sorry, negative 2x. Now, when we look at the question, we could just rearrange this that we've just written down to get dx here. Or we could look at and think, okay, there's an x as well as a dx. Can we get rid of that in one go? So there are a couple of different ways to do this. So looking here, if I bring the factor of minus 2 onto the denominator on the left hand side and move the dx up onto the top of the right hand side, I can split this statement and write a half du is equal to x dx. And that means the x and the dx in this original question can be replaced with minus a half du. Okay, so as we start to do the substitution, let's write in what we know. So as I've just said, the x and the dx I'm going to change into minus a half du. The denominator is obviously the u cubed. Okay, now if you were not going to change the limits, if you're going to wait till you get back to x's again and then use the 0 and the 2 as the x limits, then just don't write any limits on here. Okay, so let's suppose we do that to start with, and let's just tidy this up. So we've got minus a half times 1 over u cubed du. And the minus a half is just a timesing factor that's going to be there as we integrate. Let's just rewrite it as u to the minus 3, because it's not power 1 on the bottom. It's going to be the normal rule, upper power divided by the new power. So we've got the minus a half multiplying by, and then we're going to integrate this to get u to the minus 2 over minus 2. Then we could do a bit of tidying up and put the minus and the minus together to make a plus. Put the 2 and the 2 together to make a quarter, u to the minus 2. Or we could even pop the u back on the bottom to get to there. Okay, so I haven't used the limits yet. So I could either change back to x's. Okay, so that would look like this. 1 over 4 times by 5 minus x squared squared. And then I can use my limits of 2 and 0 in here. So let's do it this way first, and then we'll go back and think what would it have looked like if we had changed the limits as well. Okay, so 5 minus 2 going in there would be 5 minus 4, and 5 minus 4 is a 1. And then 5 minus 0 is still 5, and 5 squared is a 25. So we get 1 quarter, take away 1 over 100th. Okay, that's 25 hundredths, so we get 24 100ths, and we can cancel that down by dividing by 4. Or you can do it as a decimal. Okay, so that would be how you would calculate it if you weren't changing the limits. If you were going to change the limits, then you would say x is 2 and x is 0. And if x is 2, the u is 5 minus 2 squared, which is 5 minus 4, which is 1. And if x is 0, u is 5 minus 0, which is still 5. So you could have a question that looks like this. You've got your integral, and the top limit's changed to a 1, and the lower limit has changed to a 5. Now that's quite unusual, but that's perfectly possible when you change the limits, that you actually get a bigger number on the bottom limit. So you could change the limits. Okay, you're still doing exactly the same steps of algebra, but you've changed the limits as well. Okay, and as you do your integration and you've do those steps, let's just write this answer here, 1 over 4u squared. Let's suppose you've got it to that. You don't change back to x's. You've changed your limits, so you just sub in your limits. And you get exactly the same as we had over there. 5 squared I could write, but you get the same answer. Okay, and as well, remember that you can use your integration function and double check that you've done it right as well. Okay, so we could do x over 5 minus x squared in a bracket cubed, integrated between 2 and 0, and fingers crossed we get the same answer there. Okay, so you can either change the limits or leave the limits alone, but if you leave the limits alone, don't start writing the x limits in your working. Okay, you can't have mixtures of x's and u's.